Okay, we're back with 1.8 there. We're saying, right, we're looking at the number of lowercase vowels in the string. So we only want to count lowercase vowels. And we said, right, this first one is going to be problematic because if we have a string like AOU there, okay, so if we had a capital A in there, and we've already identified that basically this for loop is basically, as in all the cases, is going through each character in the string, and it encountered a capital letter, it would say, right, is the lowercase version of that in there? And it definitely would. So we don't want lowercase versions counted. I said number B looked quite promising because okay, we're saying, right, essentially we're saying, is this character, because that's the individual character, is it in A, I, U? Yes, okay, but it's testing equal to naught, and we said, what is the pos function when it returns naught? What does it mean? It means it's actually not found. It means it's actually not found. Okay, so it looked right for a second, but that equal to is the problem there. Okay, so temptations to say, oh, well, that one's greater than naught, so that's the one we're looking for, because if the pos returns something greater than naught, but the problem is that they've swapped these around the wrong way, because this is looking for A, E, I, O, U in that character, instead of the character being looked for in A, E, I, O, U. Okay, so that's the little tricks you've got to look, because sometimes we get this glimmer of hope, we say, that's the one, and then but need to analyze it carefully. So assuming the last one must be the correct answer, let's have a look. For I loop equals that. Okay, checking each character if it's in AI, and perfect. That's going to be it's only checking for lowercase. Okay, we could have used with the pos function over here. That would have been correct if we just said greater than naught. So either one of those approaches would work. So if I changed that, then B and D would have been correct. But in this case, it is only number D. This one's a nice question. May not look that nice because the code looks very long, but it's got a nice little twist in it, which may catch us out. Okay, which one of these for loops will correctly check if a cell phone number stored in S cell contains only 10 digits? Okay, so we know a cell phone number, we know like 082 883 0045 or whatever it happens to be, must have 10 digits in it. Okay, we're assuming our count is initialized to 0. So if we look at all the, and I think that's the thing when you look at it, don't get overwhelmed, because essentially they're all doing much of it. So they've all got a loop, a correct loop. Okay, and that's important to check as well. They all got the same loop, which is going from 1 to the number of characters in the string, which is pretty standard when we're processing a whole string for individual characters. And remember, we can always look at a string as the whole string by referring to the name of the string, or the individual characters with the square brackets like we've got over here. So that, when we see is it in conjunction with a loop, simply means it's going to go through every character, however long the string happens to be. Right. Let's have a look at the first one. For I loop equals 1 to the length of the string, if it's in 0 to 9, then increment the count. Okay, that looks pretty good. It'll check if it's got 10 characters, and if it's got 10 characters, it will show the message valid, and that's standard in all of it. Either shows valid or invalid just by using a show message, so we don't have to worry about that. So sort of immediate temptation to say, well, go no further, do not pass begin, do not collect 200 Rand, you've got a winner here. What about something like this? Okay, so we've got a cell phone number to, okay, now that's a valid cell phone number. Okay, and so we're checking if the count is 10, then it's right. What happens if there was a letter in there at the end? Okay, because the question says it must contain only 10 digits, no other characters. So it's not just good enough to check that you've got 10 digits in it. You've got to make sure that all those characters in there were only digits. And so that one's going to cause a problem there. Okay, it's going to check for the right number of digits, but it's not going to take into account the fact that there might be other characters that are not digits in it. Okay, so right, let's look at the next one again. And sometimes the case is that these things sort of look right, they're sort of 3/4 right, but there's just a little twist. So that first one was a very interesting one, and that's why it's sometimes important to look at the others, because it might just prompt you to think, wait a bit, why is that one right and this one also seems right? Then you know, okay, the right of the examiner hasn't made a silly mistake, as we are prone to do. Okay, this one goes through the same thing, checking the count, so that seems fine, and then it checks if the length of the cell is equal to 10. Okay, so that's getting over this problem over here, perhaps, but it's actually not checking if it's 10 digits. So let's just say there were only 9 digits. Sorry, oops, okay, so let's just say, so let me just go back there again. Okay, so let's just say instead of the last 4, I had an A. Okay, the last digit there had A. So then 9 digits plus an A. This one's going to check if the length of that string is 10. Okay, in which case it's not going to work, because yes, the length of the string is 10, so it's going to say it's valid, but it's not valid because not all those characters, not all 10 characters are digits. Okay, let's go and have a look at the last one. Okay. Right, let's look at let's keep in order and look at number C. Okay, this one's again pretty much doing the same thing as the others had, so it's checking correctly if each character in the string is in the set of digits 0 to 9. Okay, it's in the set of digits 0 to 9, increments the count, but this one checks if the length of the cell string and the count is equal to 10. And, okay, so what it's saying in this case is saying, right, you can't mess around here. For this to be valid, it must consist of only 10 characters. That's what it's checking there. Only 10 characters in that whole thing. And how many digits did you find? 10. Okay, so if that's equal to 10 and that's equal to 10, then it must be valid, because there are only 10 characters and all the characters are digits. Okay, but now number D looks very similar because it's got the same if statement, and we know that that works. So there must be something, and the for loop's exactly the same. So that it's something here it's not liking. Okay, or we shouldn't be liking. Okay, and there are two things I can see there. This one's quite sneaky, okay, because it used a different approach. Instead of saying in 0 to 9, it used the pos function, which is perfectly acceptable. It's saying check if there's characters in that one, in that set there. The problem is it didn't include a 0. Okay, that's the one problem that pops up there. So it was a little bit sneaky, perhaps. And the other thing, it tests if it's greater than or equal to 0. Now that's not going to help me, because if it came back as 0, it means it's actually not a digit. In other words, it wasn't found. So that would have to have been greater than 0. Okay, in other words, it was found. Okay, greater than 0 means, remember we said earlier, it was found. Okay, so that would have been, C and D would have been correct if those corrections had been made, but they weren't. Okay, so the only valid answer there is C. And the trick there was to say, right, it's very tempting to say, okay, let's only count 10, if they're 10 digits, we're okay. But there might have been 30 characters in the string. Okay, and 20 of them might not have been digits. So we've got to check that the length of the string is 10 and that the count is 10. And if those two things are true, it means that there were only 10 characters and, okay, and not all, and not all, and they were all digits. So length 10, all digits. That's essentially what that one's saying. Rightio, let's finish. Part 1.10 looks a little bit horrific because all the code looks really long, but again, a lot of the code's exactly the same. So it's the standard approach we've got here. It's going to look at the question now, but essentially it's going through the string snew. Okay, it's going through the length snew, and I think, to be honest, I think those should have been snew as well. My apologies there, because that automatically would have been incorrect if that had been in the test or an exam. They would have been totally incorrect because we were looking at the wrong string there. Okay, comes from copying and pasting. Okay, so let's assume that they're all snew. And what have we got here? Okay, which of these were correct if SNU is valid in terms of it must only contain digits or letters? Okay, uppercase or lowercase. Okay, must only. Okay, so if the, let's just say, oops, daisy. Let's just say we've got something like, okay, let's assume that the R count was set to 0. So let's assume that we have something like this: A, B, C, 9, 8, 7. That's acceptable. Okay, because it's only got digits or it's got letters. Okay, but as soon as it's got something like a, let's put a hash sign at the end. Okay. Okay, so how many characters in the string? 3, 4, 5, 6, 7, 8 characters in that particular example. So sometimes it helps to think of a practical example. Again, you must just guard the fact that it must take into account all of the work for any combination. So that wouldn't be valid because now not all the characters are either uppercase, lowercase, or digits. Okay, let's check this one. 1 to the length of the string. Okay, let's say that was our string, so we would go 1, 2, 3, 4, 5, 6, 7, 8. In other words, we would look at all our individual characters. Okay, however long the string happens to be. That's looking at each individual character, and it's checking if it's either in 0 to 9, A to Z, or capital A to Z, and it increments the count. So it looks like it's doing the checking. Okay, so if we ran that on this particular string, it would count 3, 4, 5, 6, 7, and the hash sign wouldn't be counted because it's not a digit, and it's not a little letter, and it's not a big letter either. Okay. Then the test is it equal to the length? The count that I've just made, is it equal to the length? And no, it wouldn't be, because if I came through here, we've just said it would count ABC, that's 3, 4, 5, 6, 7, but the length of this thing is 8. Okay, which means somewhere along the line there's something that's not a digit because it wasn't counted. Okay, only if the number of characters found are valid is the same as the number of characters in the string. In other words, if there are 10 characters and the count's 10, then it must be right. If there are 20 characters and the count's 20, it must be all right. But it's not. Okay, so this in fact looks like the correct answer. Let's have a look at the others here. Okay, and see why they're wrong. Okay, this looks problematic because it didn't check in any way for lowercase. Okay, it only checked for the uppercase letters. It didn't make any difference to that one. Okay, so that one we would reject. This one, for some weird reason, is just checking if the length of the string is 10 characters. It's got nothing to do with it. Okay, we don't know how long it shouldn't make any difference. And this one's similar to the first one, looks exactly the same. First two lines are the same. Okay, but this is different here, and that's sometimes what you need to say, right? Well, what's different? This is checking if it's less than or equal to. No, it can't be less than or equal to. Like in our example, there's I count 7, but the length is 8. So it can't be less than. That doesn't qualify. So only if it's equal to be said that it's meets the criteria, because it's the same number of characters as the length, and it's all those characters that were counted were either digits, little small letters, or big letters. Okay, so there's just some tactics involved there as well in terms of answering multiple choice questions. In terms of sometimes having a look. If you're dead sure that it's the correct answer, but if you've got the time, always just have a gander through it. I know sometimes people get a little bit freaked because then they start to have self-doubt. But just think about, and also think of practical examples. In other words, like applying it to the string in your head or on a piece of paper, or whatever it happens to be easiest to do. That's the end for multiple choice. Let's go and have a look at questions.